Okay, it's time to go. Okay, so thinking about resolving ambiguous calls, and there are different rules in order to find a match. But when a call is ambiguous, meaning that the arguments can be resolved to successfully call one overload, but the same step actually makes it eligible to call another overload instead. Therefore, it's ambiguous, like having a float to a character or a Boolean, or a character and a long double, or a long double to a float and a character. Any of these kinds of things that are, doesn't have to be a numeric conversion, but we're one step. Like promotion, there's only one way to promote, so promotion would be favored over. Oh my god, that dog fucking scared me. I didn't think he'd be at the window. I'll wait till he starts barking and then let him in. Maybe? Yeah. Okay. So, let's go back a little. Yep, ellipses, and then compiler error finally. Either resolve to one, there's no match, or there's an ambiguous call. I.e., either there's no call, so nothing was found, nothing's relevant, so compiler error, there's no function that takes those parameters, or we call the function, or we get an ambiguous call, third outcome, or ambiguous match. Like an ambiguous match would be like, I'm including IO stream too much. At some point, I'm not going to include any header files. I'm just going to test stuff as is. See if I can write some things. In this case, let's just get our main going. And yeah, we can do that. Float. What is this? We'll just call float convert. Whatever. Float test. It's fine. Cool. And or let's say the output doesn't matter actually. It'll be void, and this one takes a float. But there's another overload that takes a character. And we're going to call test with 3.0. This is ambiguous because we're converting from a double down to a float or over to a character. Boom. Ambiguous call. Because more of them match, more than one match this argument, meaning that this argument, when it's converted to match one of them, that conversion also matches the other. So there's no way for it to know which to use. Same step. Yes, the same step makes them both eligible to be called, which makes them ambiguous. Same thing. A long over numeric conversion to a double or down to an int. Yep, so there's no exact match. It tries to promote, but it can't promote. And then it tries to convert, and then it finds that it will do it for both. Yep. And the point is that, sure, if it converted to a double, we're cool. If it converted to an int, we're cool. But it didn't. It's ambiguous. We have to pass it explicitly if we want to do that. This is a long. If we instead do a static cast, to an int, then we're cool. Because we're saying, hey, we're calling this, and this value explicitly matches here, resolves the ambiguity. Or we could static cast it to a character, same thing, resolves the ambiguity. Why? Because characters, what about bool? Bool as well, cool. So characters and booleans are technically, all of those are integral types, which means that they can be promoted up to integers. So because this takes an integer, well, we convert this guy to a bool, from a long to a bool, and int64 to a bool, and that promotes to an int, but it numerically converts to a float. And promotion takes priority, precedence, over numeric conversion. Yep. In this case, there's nothing explicit, so it doesn't know which one. In this case, it says ambiguous call. Mine doesn't say could be this or could be that. Let's see. Oh. Oops, there's an identifier there. If I go inside the compiler error that says there are more than one instance, there are different instances, and it's probably going to tell me which one each takes. Yep, so there's test float and there's test int. One takes float, one takes an int. This is a long. Long has to go over to a float or down to an int. Argument types are long. Yep. Therefore, it doesn't know which one. Zero is an int is over to an unsend or an int is over to a float. Numeric conversion, ambiguous. 3.14159. That is probably a well, yeah, it's a double because it's not explicitly said to be a float via the f suffix. So it's either down to a float or over to an unsend. Same shit here. Both. Numeric conversion for both. If you thought 0 would be unsend, well, dummy, literal integer values, or literal integral values are floats by default. Or, integers by default. Yep. Yes, that's because this is an int value. Yep. A default argument. Oh, you're talking about... Hey, I never... Oh, we're going to see it soon, but I never see default arguments. And it's, what was it? The types can differ, but there's some specific syntax about it. Like maybe... What is it? Is it that you have to do copy assignment? I don't remember. Okay, and so we'll do void test null. Okay, let's say int x3. Or maybe it has to be int x is 3. Yeah, it does have to be copy assignment at least, looks like. And then we can just say, hey, use x. What if we did x3 There's an issue at lines 2 and 1, so yeah, it's this initialization here. Same thing with braces. Oh, I thought it was cool with value initializing. I was going to say, I don't know why it would be. But it's cool with copy assignment. Okay. Yes? Yeah, because if C++ is strongly typed, and the type of variable can't be changed after it is created, instantiated, defined, then the type of shit that these functions are going to be called with, the arguments, types, are already known at compile time. So it can be called later, but the things that call it must still actually be able to call it. Yeah, so if we find a value and we're saying, hey, we need to call this function for this particular type of value, like if we say add, and the add function can take two floats, or a float in this, or this and this, whatever. Well, the parameters would be whatever those are. So there could be the int parameter add. There could be the float int. There could be this and that, the other thing. The point is that we add another overload that matches what we're calling it with. So if I have an attack function and I'm passing it particular data types for the damage, well, it might just make sense for me to put an unsigned int into the attacking function's signature. Because, sure, it's an unsigned int, but you can't do negative damage to somebody. I can't heal him when I hit him with my sword. 0 is the lowest it goes. Yep, and then we have an exact match. Or, I mean, it would work. You wouldn't want to do it, though. But, unless there's a reason. But you could make another function overload and then give it a type that is prioritized earlier than the others when they resolve. So, like if we had a float function and a bool taking function. But a bool gets promoted to an int anyway. Fucking dog. Alright, I gotta bring him inside, damn.